Hello everyone, today in this video we'll be discussing about the first module of OS. Super important questions I've taken from the previous schemes, 18 scheme, 21 scheme and 22 scheme based on the syllabus. So these are very important questions, don't miss any of them. And before starting, please do like and subscribe, it helps me make more videos like this. So without wasting any more time, let's get started. I'll be telling you all the key points you need to remember from the exam point of view. Okay, so the first question is explain the following terms. Okay, so there are four terms given to us. The first is multi-programming, second is multitasking, third one is multiprocessor system, and fourth one is clustered systems. Okay, so what do you understand by the term multi-programming? Okay, multi means many, programming means programming, right? So multi-programming means many programs are being run. Okay, you need to remember this. Many programs are being run. Now, how exactly is this happening? One of the most important aspects of OS is the ability to multi-program. Okay, that is the ability of OS to multi-program. Multi-programming increases the CPU. Okay, the CPU does the tasks. Okay, it increases the CPU utilization by organizing the jobs. Okay, so that CPU is always has one to execute. So what happens, CPU has to complete some tasks. Okay, so what happens if some task is hold at some time, if the jobs are organized in such a way that every time one job will be there which CPU is executing, that will save a lot of time, right? So we will be able to execute more tasks in less time. That is what is called multi-programming. How you set it according to the execution, so that CPU is always executing some or the other tasks. Okay, the operating system keeps several jobs in the memory as shown below. So this is the memory, here this is the OS, and here are the different jobs which needs to be executed. Okay, and the sequence is set so that every time one job will be there which CPU can execute. This is useful in situations where one job requires input from the IO. Okay, input output. So whenever there is a job which requires an input from the user, at that time there is a wait, right? Because the job is waiting for an input. At that time, CPU can do some other task until the input comes here, right? That is what is multiprogramming, and CPU can take up some other job in the meantime. Okay. Next is the multitasking. Okay, multitasking means different tasks are being performed at the same time. This might look similar to multiprogramming, but there is a difference here. Okay, it is also called as time sharing. Okay, in multitasking or time sharing system, a single CPU executes multiple tasks by switching among them. Okay, so understand this, let's take an example. Okay, if we take an example, if it is having job 1, job 2, job 3, suppose 3 jobs are there, and this is the CPU. So CPU can execute first job, second job, and third job. Okay, like that it will execute very fast. First it will execute this, after 1 second this, after 1 second this, then next second this, then next second this, then next second this. Okay, like that each second will be divided here, and it will not be in actually in second, it will be in milliseconds or microseconds. Okay, it will be continuously divided and switched, so that it looks like to us humans it will look like every job is executing parallelly, but that is not the case. Actually every microsecond this is and this getting executed one by one. Okay, that is what is called multitasking. Okay, in multi-programming what happened there, one task was there, and until this task is getting executed, it will not change until it waits for an input or output operation. At that time something else will be executed. Okay, here all are getting executed equally, means little time is given for every job, like that. Okay, this switches occur so frequently that the user feels all programs are being executed at the same time. Okay, so it is very fast switching, so we think that all jobs are executed at the same time. Time sharing requires an interactive system. Okay, so that user can interact with the program running. Accordingly, the response time should be short, typically less than 1 second. Okay. Next is multiprocessor system. Here there are multiple processors. What does processor do? Processor performs the process. Okay. Multiprocessor system have two or more CPUs. Okay. Just as I told you here, this one CPU can perform multiple tasks here, but sharing the time among them. Like that, if there are more than one CPUs, that multitasking will be multiplied, right? This can perform three, this can perform three, this can perform another three. The having the multiple CPUs is called multiprocessor, because CPU is central processing unit. If there are multiple processors, it will have multiple CPUs. Okay, and also they are in close communication. They share the bus, clock, memory, peripheral devices, all those things they will share among each other. Okay, different CPUs. The multiprocessor system have three main advantages. Three advantages are there. Increased throughput means the output will be more. If there are more CPUs, we'll get the more output. Economy of scale. Okay, to scale them, it's easier and cheaper. Increased reliability. There will be more reliability if there are more CPUs. Okay, failure chances will be less. there are two types of multiprocessor system: asymmetric and symmetric. Asymmetric means master slave. Okay, so there will be one master CPU and there will be slave CPUs. This kind of representation is asymmetric representation. Second is symmetric. All the processors are considered as peers, means all the CPUs will be equal and each can share the data among each other. Okay, like that, it is peer to peer. Moving on to the fourth one, which is clustered systems. Okay, what do you mean by clustered? Cluster means group of something. Okay, like that. See, this is called one cluster. Okay, group of something. Clustered systems are two or more. Okay, how many? Two or more individual systems connected via a network. There is a network, and because of a network, there is an interconnection between them and sharing software resources. The resources which are there, that is being shared among all these systems. Okay, that is called as a clustered system. It provides high availability of resources and services. The services will continue even after the cluster, even after one cluster or more cluster fail. Okay, because since they have shared among each other the data, if one cluster fail, it doesn't matter, the other two can handle the continue with the tasks. Okay, so that the other two will handle it. That's why because of one cluster fail, the entire system won't shut down. Okay, and there are two types in that: asymmetric and symmetric. Asymmetric means one system is in hot standby mode and other systems are running. If this is the thing where one system is in standby mode, other systems are running, it is called as asymmetric. If it is symmetric, it will have two or more systems running the applications at the same time. It will be running the application. Okay, that is symmetric. That was about the first question. Moving on to the second question: explain the operating system. Okay, what do you understand by the term operating system? Operating system is a system software that acts as an intermediary between the user of computer and the computer hardware. This is the user, this is the hardware, and this is the OS in between. Okay, this is the OS in between. User interacts with the OS to interact with the hardware. Okay, and hardware sends the response which will be sent back to the user. So what is there in between, intermediary, that is called as operating system. Okay, it is a software system software that acts as an intermediary between the user and hardware. Okay, then what are the goals of operating system? There are four goals of operating system. Okay, what are the goals? Make the computer system convenient to use. Okay, the OS, whatever is installed, that OS should be able to make the computer easy to use for the end user. Okay, end user should be able to easily use the system. Use the computer hardware in an efficient manner. Okay, efficiency should be there. Provide an environment where user can easily interface the computer. Okay, an environment should be provided where user can use the computer. And also it is a resource allocator. The OS will allocate how which process we should get what resources. Okay, so that is why it is called as resource allocator. These are the four goals of operating system. If these four goals are there, that is called a very good operating system. Okay, that is about the operating system. Moving on, we have the dual mode operating system with a neat diagram. Okay, dual mode means two modes are there. Okay, the system can be assumed to work in two separate modes: user mode and kernel mode. Okay, there are two modes: user mode and kernel mode. Let's understand what it is. A hardware bit indicates if the system is in kernel 0 or user 1 mode. Okay, so kernel is denoted by a 0 bit and user is denoted by 1 bit. So whenever the hardware bit is 0, it means it's in kernel mode, the system is in kernel mode, and whenever it is 1, it means the system is in user mode. Okay, now what is the difference between them? When the system is executing a user application, it is in user mode. Means when we access the computer, like currently I'm making a video on this computer, so I'm the currently the system is in user mode. Okay, and when the user requests an application service, okay, whenever our user requests an internal command to be run, an internal some service should be run, at that time it will be in the kernel mode, because internal services and memory fetching and storing, saving data, deleting data, and clearing the recycle bin, all those things are the handled by the kernel. Okay, internal system. Kernel means internal system, and user means we from outside the computer we are operating it. Okay, the following diagram shows the transition from user mode to kernel mode. Okay, initially we will be in the kernel mode whenever we turn on the system, because when you turn on the system there will be some loading and the booting operations and the functions will be running. That is in kernel mode. We cannot have any control when the computer is in kernel mode. After the computer gets on, we'll be able to use it. That is the user mode. Okay, until we unless we run any application and in that application some process starts happening, then it will be in the kernel mode. Okay, so here is the diagram. So in this diagram, you can observe two parts here. The first part is user mode bit. Second is kernel mode bit. Okay, this is the user perspective and this is the kernel perspective. Initially, what happens? User process is executing. Suppose that I have opened a notepad and started typing. So that is a user process which is executing. Then call system call. Whenever a call is made by the user to access the kernel, at that time trap will happen. Trap means the control will go from the user to the kernel, so user will not be able to control the system anymore. Okay, and it will go to the kernel mode and the bit will become 0, and here the call will be executed. Whatever the thing has to be performed, whichever service or the process has to be performed, it will be performed. After it is done, return mode bit will be equal to 1, so again it will become back to the user mode. Okay, this is how the transition happens. Okay, the dual mode helps the system protect against the errant users, means the users which make some errors and they make some changes or modify the internal system. The dual mode helps the system to protect against those type of users. Okay, and whenever we are in the kernel mode, the user won't be able to make any change. Okay, they will lose all the control, so that will protect the system from making any unwanted changes. Okay, so by switching to the kernel mode when illegal attempt is made. Okay, only the super user, okay, super user or root user or the admin, they only can access the kernel mode. Okay, they only can access the kernel mode, rest of the normal users cannot access it. Okay, moving on to the next question. With a neat diagram, explain the concept of VM. What do you mean by VM? Virtual machine. Okay, what do you mean by virtual machine? See, virtual machine is an imaginary machine. Okay, what it does, it abstracts the hardware of a single computer. Abstract means it takes a imaginary image of a real machine hardware. Okay, like you can take it as a copy. Virtual copy means imaginary copy of a hardware, like the CPU, memory disk, drives, network interface, cards, and so forth. All these things, an imaginary image will be created in the memory. Okay, into several different execution environments. Like that, many other different copies of images will be created of the hardware. Okay. Now, what do these imaginary images do? Okay, it thereby gives illusion that each separate environment is running in its own private computer. So what happens here is we divide the hardware into different copies, imaginary copies, and each will be assigned a different OS, okay, operating system. So it will look like all of them are executing different systems, but in reality they are referring to the same hardware. Okay, it creates an illusion that a process has its own processor with its own memory, but the processor as well as the memory is being shared actually. You'll understand this when I show you the diagram. So here host OS is the main OS. Okay, suppose that there is one system here. This is of Windows. Okay, Windows operating system, and I want to make this as virtual machine. So I'll divide the memory into different parts here and make this all as different OS. But internally, this will be connected with the same memory. This is called as host OS, which is connected with it. So which is connected with this? This was the Windows operating system. Okay, initially what is there originally, that is the host OS, and whichever we make after dividing it, the other OS installed in the system are called guest OS, the different ones which come later on. Okay, so this is the diagram here. This is the non-virtual machine. Here whichever process is there is related to the same kernel and hardware. Okay, so only one operating system will be there, but here there are multiple operating system 1, operating system 2, operating system 3. They will be having their own kernels, and they will be having their own virtual representation, and hardware will be shared between them. Okay, so these are all actually the same system only, but we will divide it in the imagination that they are different ones and they have their own kernel, but actually they all point to the same kernel only. Okay, so here we can run different os1, os2, os3, and so on. This is called as a virtual machine. Okay, why do we use virtual machine? In a virtual machine, same hardware can be used to execute different os environments. Okay, so if there is a requirement to perform one task in a different os, suppose that we want to perform one task in Mac but we have Windows, so we can create a virtual machine which will install the Mac system whatever is required, but it will be referring to the same hardware and the kernel, but we'll be able to execute the Mac environments. Okay, Mac services will be able to execute. Okay, this is called as a virtual machine where different OS will be run. Okay, but the hardware will be shared among them. Moving on, we have also an example related to the virtual machine, which is called as VMware. This is also asked in the exam in the previous year papers. VMware is a popular commercial application that abstracts Intel 80x86 hardware into isolated virtual machines. So this is abstracting this particular hardware. Okay. So VMware runs as an application on a host such as Windows or Linux. So which is the host? Windows or Linux. So if you have a Windows system or a Linux system, you can install VMware and make your own virtual machine. Okay. And also this allows the host system to concurrently run different guest operating systems. Okay. Once VMware is installed, we can run Mac on it, we can run another Windows on it, like for example Windows XP or Windows Vista. We can run the another one Linux also we can run. If any other system is there, BSD is also another system that also we can run. Okay, that is called as guest operating systems, and they are independent virtual machines. The following diagram shows the implementation of VMware. Okay, so this is our guest OS, this is another guest OS, this is another guest OS, this is the virtualization layer, and here we have the host operating system, which is Linux. Okay, and the hardware, memory, and the devices, CPU, all will be shared to all of these. Okay, and every of them can be accessing all of the hardware of things. Okay, so this is how the VM is implemented. Okay, and this is example for the VMware. Okay, in case if they ask in exam, then only you need to write about the VMware, or else the theory of virtual machine is sufficient. Okay, explain the services of OS that are helpful to the user and the system. Okay, operating system, what it does, it will provide some services or the functions or doing some things, tasks. So it provides all of those, and those things are helpful to the user as well as system. So we have to explain which are those things. Okay, so an operating system provides an environment for execution of programs. We have many programs we want to execute it, so it provides an environment where we can put these programs and execute. Okay, that is what operating system does. There are some services provided by operating system for system and the user. We'll discuss each one by one. First one is OS provides services for the users, including. Okay, so there are some services provided by the for the user. Okay, let's discuss each one by one. The first one is user interfaces. Okay, means by which users can issue commands to the system. Okay, so OS, it provides the command line interface, which is the CMD. The CMD we have in the system, right? CLI, command line interface. So that is provided by OS. Why it is provided? So that user can give the commands and the system can perform those commands. But in between that, we should have a translator or an agent. That agent is the CLI, or command prompt. Okay, so that will give commands and the commands will be taken from here, and this setup is done by OS. Okay, second one is program execution. When we want to execute some programs, we'll be using the OS provided program execution. So OS must be able to load a program into the RAM, run the program, and terminate the program. All the process related to program, such as putting it and running it and executing it and exiting it, terminating it, all those things are handled by OS. Input output operation, we want to send an input, we want to get an output from the system, that is also handled by OS. File system manipulation, such as creating the file, reading the file, writing the file, modifying the file, searching the file, and listing the content of the file and changing the file permission, all those things are provided by OS. Okay, the other one is the communication. Okay, communication means inter-process communication, or IPC, either between the process running on the same processor or different processor. So there will be different processors present. Okay, they will be performing different tasks, and OS will ensure that there can happen communication in between them wherever it is required. Okay, the last one is the error detection. Both hardware and software process do some errors, so that error should be detected and modified and corrected, right? So error should be corrected, that is also handled by OS. So totally six things are provided by OS: user interface, program execution, input output operation, file system manipulation, communication, and error detection. Okay, similarly, the OS also provides services for the system. Okay, efficient operating of the system. So those include three services. First one is resource allocator. So OS helps the system allocate the resources, like how much CPU should be allocated, the main memory, storage space, input output devices must be allocated to the multiple users and multiple jobs at the same time. Okay, this is a very thoughtful task. Why? Because how much resource should be allocated so that all the operations happen successfully. That is a very complex task that is handled by the OS. Okay. Second is accounting. There are services in the OS to keep track of the system activity and resource usage, how much system is being used and how many resources are being used. That track is kept by the OS. Okay, that's second thing, accounting. Third one is protection and security. Protection involves ensuring the access to the system resources is controlled. Okay, like the system resources which are there, that should not be accessible to everyone. That should be only accessible to the ones who are authorized to access it. And security of the system should be provided from the outsiders. It must also be done by the means of a password. Okay, when password is kept, the system will be more secure. Okay, so these are the important questions from the exam point of view, and don't miss any of them. It's very important. And thank you so much for watching. Please do like and subscribe, and I'll see you in the next one.